There is a moment, a fraction of a second, right at the base of a rocket during liftoff, where the temperature hits 6,000 degrees Fahrenheit. That is hotter than the surface of the sun as seen from Earth. And NASA puts cameras there, cameras designed to stare directly into that hell and keep recording. And what those cameras have captured, on the pad, during ascent, through booster separation, through the chaos of 8.8 million pounds of force tearing a machine off the face of the planet, is some of the most terrifying, most jaw-dropping footage human beings have ever produced. This is the story of what NASA's rocket cameras actually see during liftoff, what they have captured that nobody talks about, what happened when the most anticipated launch in a generation that went up on April 1st, 2026, and what the cameras caught that made the entire internet stop breathing. Let's start with the basics, because most people have no idea what is actually involved in filming a rocket launch. When you watch a launch on your screen and see that clean, dramatic shot of the rocket rising through a wall of steam and fire, that shot did not happen by accident. It happened because engineers spent months figuring out how to put a camera close enough to capture the moment, while ensuring that camera would survive an environment that destroys nearly everything placed inside it. NASA's Space Launch System, the rocket that just carried the Artemis II crew toward the moon, is the most powerful operational rocket on Earth. At the moment of ignition, its 4 RS-25 engines and 2 solid rocket boosters combined to produce 8.8 million pounds of thrust. To put that in terms your body understands, that is roughly the equivalent of 160,000 car engines firing simultaneously, all pointed at the ground, all within a structure the size of a 30-story building. The shock wave that travels outward from the pad at the moment of ignition is strong enough to shatter unprotected glass at a considerable distance. The sound alone, at the source, would kill an unprotected human being. And yet, cameras survive this, not by luck, by engineering. NASA has spent decades developing specialized ruggedized camera systems capable of operating in conditions that would instantly destroy any commercial equipment. The cameras mounted on the exterior of the SLS rocket are built on a platform called the Imperx Bobcat, a system that NASA engineers spent years modifying with custom heat-resistant housings, internal heaters, and military-grade connectors capable of withstanding the violent vibration of liftoff. These cameras are not simply bolted to the rocket and hoped for the best. Every mount, every cable, every lens housing is engineered to absorb vibration patterns that would shake a standard camera apart in under a second. The electronics inside are hardened against radiation, against temperature extremes that swing from the heat of liftoff to the cold of space, sometimes hundreds of degrees of variation within the same mission. For the Artemis missions, NASA placed a total of 24 cameras across the rocket and spacecraft. 8 cameras were mounted on the Space Launch System itself. 16 more were distributed across the Orion spacecraft. Each camera had a specific job. 4 cameras around the engine section at the base of the rocket were pointed upward, looking toward Orion from below, capturing the fire and chaos of ignition from underneath. 2 cameras at the intertank position, near the top of the solid rocket boosters, were positioned to capture booster separation. The moment when those 2 enormous fuel columns, each 177 feet tall, detach from the core stage and fall away while still burning. 2 more cameras on the launch vehicle stage adapter captured core, stage separation further up in the ascent sequence. These cameras operated on a pre-programmed automated sequence during launch, cycling through their shots with no human operator controlling them in real time, because no human could react fast enough to the events happening in those first 2 minutes of flight. And then there was the rocket cam, the external camera mounted on Orion's crew module adapter, pointed back down at the SLS rocket below. This is the shot that viewers around the world see during NASA launches, the rocket growing smaller as the spacecraft climbs, the atmosphere thinning, the curvature of the Earth beginning to appear at the edges of the frame. This is one of the most recognizable shots in modern spaceflight. And on April 1st, 2026, as Artemis II lifted off from Launch Complex 39B at Kennedy Space Center at 6:35 in the evening, millions of people around the world were watching their screens waiting for exactly that shot. What followed was one of the most dramatic, most chaotic, and most revealing launch broadcasts in NASA's recent history. And what happened revealed something important not just about cameras, but about the tension between engineering reality and public expectation. The launch itself was a genuine triumph. The SLS rocket, a machine with a long and complicated history of delays, fuel leaks, and launch scrubs, cleared the pad cleanly on the very first attempt. It fired at almost the exact start of its 2-hour launch window. The twin-solid rocket boosters ignited perfectly, delivering more than 75% of the thrust needed to lift a 5.75 million-pound vehicle off the Earth's surface. The combined ignition produced that wall of white steam, not smoke, but superheated water vapor, from NASA's water deluge system, which releases approximately 450,000 gallons of water across the mobile launcher and flame deflector to absorb the thermal energy of liftoff. That water system is itself a piece of engineering that most people have never thought about. Without it, the acoustic energy and heat generated at the base of the pad would reflect back upward into the rocket's structure, potentially causing catastrophic damage to the vehicle before it even left the ground. Pilot Victor Glover, speaking from orbit the following day, described the moment of liftoff as surprising even to the 4 trained astronauts strapped into the Orion capsule above. They had spent years preparing for delays, scrubs, technical holds. The SLS had a well-documented reputation as a difficult machine, and then it simply worked. Clean. On time. First attempt. Glover said the crew had tried to prepare themselves without having expectations, but that somewhere in the back of their minds, they had hoped it would happen. And then it did. 4 human beings, Commander Reed Wiseman, Pilot Victor Glover, Mission Specialist Christina Koch, and Canadian Space Agency Mission Specialist Jeremy Hansen, were on their way to the moon for the first time in over 50 years. But while the engineering was performing flawlessly, the broadcast was entering chaos. And this is where the rocket cam story gets genuinely fascinating, because what happened during the Artemis II livestream exposed something important about the gap between what cameras can capture and what broadcast systems can deliver. Within seconds of liftoff, several of the ground-based cameras in NASA's feed simply went black. Not because the cameras failed, but because the operators switched feeds at the wrong moment, or the broadcast director cut to an angle that showed nothing useful, or the tracking system briefly lost the rocket in the frame. The live zoom on the rocket itself became so erratic at one point that viewers described it as looking like someone having a seizure. The moment of booster separation, one of the most visually spectacular events in any rocket launch, when those 2 enormous columns of fire peel away from the core stage, was missed entirely on the main broadcast feed. NASA's production team cut away to a wide shot of spectators looking up at the sky at the exact moment the separation happened, then cut back to find the boosters already gone. The internet reacted immediately. A Reddit post in the Artemis II launch megathread described the production quality as catastrophic. One user summed up the collective frustration by writing that the whole thing felt like someone had suddenly realized that day was launch day and rushed out with whatever equipment they had available. Another pointed out the fundamental absurdity of the situation. This was a rocket launch, possibly the most predictable event in terms of timing and location that humans can produce. And yet, the camera coverage felt improvised. The post accumulated over 23,000 upvotes within hours. Someone described the $4 billion rocket receiving $4 camera work. And every time the screen went black or the feed froze, thousands of viewers reported the same visceral reaction, a flash of certainty that something had gone catastrophically wrong, and NASA was cutting the feed to hide it. That reaction, that flash of fear when the screen goes dark, is worth sitting with for a moment because it reveals something real about why rocket cameras matter so much. When you're watching a crewed launch, you're watching 4 human beings riding an explosion into the sky. Your nervous system knows this, and the camera is the only connection you have to the truth of what is happening. When that connection cuts out, the imagination fills the gap. And the imagination, in this context, always goes to the worst possible place. This is why the footage from cameras bolted to the vehicle, recording automatically, with no broadcast director able to cut away, carries a weight that no studio camera can match. Those cameras tell the truth without anyone editing it in real time. What they show is what is actually happening, and what they show during a launch is genuinely terrifying. The infrared footage from the Artemis II launch, released by NASA in the days after liftoff, showed the SLS engines in a way visible light cameras simply cannot. In visible light, detail in the plume and engine bells gets washed out by the surrounding atmosphere. In infrared, the sky goes nearly black. Against that black, the heat signatures of the engines become something else entirely. Structures of intense, organized thermal energy, turbulence visible in the exhaust that no standard broadcast feed can show. The infrared images of booster separation look less like engineering and more like something from a different category of experience entirely. National Geographic captured the Artemis II launch at 2,000 frames per second. At that frame rate, a single second of real-time liftoff becomes 83 seconds of slow motion. The ignition sequence, which appears almost instantaneous in broadcast, unfolds as a choreographed chain of events. The solid boosters ignite first, the wall of steam builds, the hold-down bolts release. The rocket rises, not explosively, not suddenly, but with a terrifying deliberateness, as if something impossibly heavy is choosing to move. Within the plume, shock diamonds appear. Those distinctive bright structures that form when exhaust pressure exceeds the surrounding atmosphere. They are a signature of supersonic flow, and they are extraordinary. The cameras buried in the flame trench underneath the pad, pointed at heat-resistant quartz mirrors, capture something even more extreme. They occupy a position no human can hold at the moment of ignition. The footage shows the flame deflector absorbing thousands of tons of force per second. It shows the water deluge activating, 500,000 gallons, preventing acoustic energy from reflecting back into the vehicle. It shows a world of fire and pressure that exists entirely outside normal human experience. These are the cameras that matter most, not the ones a broadcast director switches between. The ones bolted to the vehicle, running their pre-programmed sequences, recording at the exact points on the machine where failure, if it comes, will first become visible. It was those cameras, the high frame rate units on the launch tower, that captured the puff of smoke from the Challenger's right solid rocket booster on January 28, 1986, seconds before catastrophe. That footage told the truth, frame by frame, even when everything else was ambiguous. That is what rocket cameras are at their core. They are witnesses. They are positioned in places where the stakes of what they observe are absolute, where what they record may be the only objective record of whether everything went right or something went terribly wrong. For the Artemis II mission, which carried 4 human beings farther from Earth than any human has traveled in over 50 years, on a 10-day journey that looped them around the moon and back, everything went right. The launch was clean. The solid rocket boosters separated perfectly, peeling away from the core stage exactly as designed. The solar array wings on Orion deployed and locked into position, drawing power as the spacecraft climbed toward its lunar trajectory. The crew survived. The mission is proceeding, and NASA's cameras, mounted across 24 positions on the rocket and spacecraft, recorded all of it. The fire, the separation, the ascent, the moment the Earth began to shrink in the frame. The broadcast may have been a mess. The production may have felt improvised. The cameras on the ground may have missed the moment of booster separation, while the director cut to a crowd looking upward. But somewhere on the exterior of the Orion spacecraft, a camera mounted on the crew module adapter was pointing back at the SLS rocket below, watching it fall away as the spacecraft climbed higher, watching the plume fade, watching the world grow smaller and rounder and quieter behind them. And that shot, silent, underrated, automatic, indifferent to broadcast schedules and camera operators, was the most honest thing recorded that evening. The rocket had done its job, the cameras had witnessed it, and 4 human beings were on their way to the moon. That is what it looks like when something works. That is what terrifying and miraculous look like at the same time. There is one more layer to this story that deserves its own moment. In the days after the Artemis II launch, as social media debated the broadcast quality in armchair, directors rewrote the production in their heads. NASA quietly released the infrared footage. No fanfare, no press conference, just the images, black and white, stark, showing the SLS in a register of light that human eyes cannot naturally perceive. And the reaction was completely different from the reaction to the broadcast chaos. People stopped complaining, because the infrared images showed something that no standard broadcast camera could have shown, regardless of how competent the director had been. They showed the actual thermal architecture of an 8.8 million pound thrust event, the patterns of heat across the engine bells, the way the exhaust plume organizes itself into structured flow in the first milliseconds after ignition, the precise moment when the solid rocket booster's thermal signature separates from the core stage. These images matter beyond their visual impact. They are data. Every frame of infrared footage from a rocket launch is a data point that engineers analyze to verify every component performed within its thermal design limits. If a part of the engine bell shows an unexpected hotspot, that is a signal. If any external surface shows a temperature anomaly during ascent, that is something to investigate before the next flight. And the cameras are not just for the public. They are instruments. This is why, when a camera survives conditions that should have destroyed it, the story is worth telling. In 2018, a NASA photographer named Bill Ingalls placed a Canon DSLR roughly a quarter mile from a SpaceX launch pad at Vandenberg to document a Falcon 9 launch. A brush fire ignited by the rocket's exhaust engulfed it before firefighters arrived. The housing melted, the electronics were destroyed, but the memory card survived. And on it was a single frame of the Falcon 9 lifting off, captured in the last instant before the camera died. It literally died doing its job, and its final image was the exact moment it had been placed there to witness. The cameras that NASA bolts to its rockets are not glamorous equipment. They are ruggedized, heat-resistant, vibration-hardened working tools built for one purpose: to be present at moments of absolute consequence and record what happens without editing. They run their sequences regardless of what the broadcast director cuts to, regardless of whether the live stream freezes, regardless of whether the internet is watching or complaining. They are the most honest cameras in existence because they have no choice. The universe does not give them an alternative. And what they captured on April 1st, 2026, at 6:35 in the evening above Kennedy Space Center, 24 camera positions across a machine carrying 4 human beings toward the moon, was the truth of one of the most dangerous and extraordinary things our species has learned to do. The truth was 8.8 million pounds of controlled fire. The truth was shock diamonds in a supersonic exhaust plume. The truth was 2 solid rocket boosters peeling away at altitude, still burning, falling back toward the ocean. The truth was, the Earth shrinking in the rocket cam's frame and the darkness of space replacing it. The broadcast was a mess, but the cameras bolted to that rocket never missed a frame. And no amount of production chaos changes the fact that when the moment came, those cameras were exactly where they were supposed to be.